project. So Jack did a really nice introduction to the project yesterday, and Simon also touched on it on his talk the other day. And so my personal research, my PhD, is taking the SWORD project and applying it here in South Africa for Indian Ocean humpback dolphins. One thing that Jack didn't do yesterday, and I'm going to call him out now, is actually tell you what yes I am, is what a signature whistle is. So we're using these as individual markers in a framework in our research, but these are actually a type of whistle that these dolphins produce. They are a learned, individually unique whistle type in a dolphin's repertoire. They're formed as a calf in a mother-calf pair, used for cohesion and contact, and they stay stable. So they stay stable throughout the animal's life. And they're often referred to as like a name, although that is the animal producing it themselves. A lot of this work is done in captivity and in bottlenose dolphins over the last 60 or so years, with more recently more and more species coming out, more research on these species, other species coming out with suggested signature whistles in those species as well. And we, like Jack did say, we use a SIG-ID. It's called SIG-ID, but it's a bout analysis approach for whistles in the wild to identify these specific whistle types. So up in Namibia, they've been doing a lot of research since about 2008 into the resident population of bottlenose dolphins up there. And they have a really lovely photo ID catalogue. And as Jack was saying yesterday, there's a really lovely also signature whistle catalogue up there. And they did some market capture models, and they've come out to the similar estimates using both methods. And a lot of Jack's work is looking into that fine scale distribution. So how can we maximize our probability of detecting these signature whistles to then use them in a market capture framework going forwards? So for the Brits in the room, it's all about location, 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 especially in bottlenose dolphins. But I'm now taking that framework and I need to apply it to another species, to an endangered species here in South Africa, one where we don't have an extensive background in knowledge on their acoustic repertoire, and especially not in terms of their signature whistle use at all really here in South Africa. So there's 4 species of humpback dolphin across the globe. All of them are threatened on the IUCN Red List. Here in South Africa, Susa plumbea are endangered. They're a global species, but extremely coastal. And down here in South Africa, we're actually at their most westerly range. So we kind of describe it from False Bay or Muizenberg even, all the way through to the Bay of Bengal for the Indian Ocean humpback dolphin. And like Simon said the other day, they're absolutely a menace to work with on a boat. They are extremely coastal. They really love to hang out in the shallow water where the surf is. They have very low encounter rates and a very small population throughout their global range. And so traditional methods of photo ID have been traditionally really hard, and a recent review paper collated a lot of photo ID available over the last 16 or so years from around South Africa, and came up with around 407 unique individuals through photo ID, and they put the total population at around less than 500. And you can really see how coastal range they are there, and that puts them at a real forefront of a lot of threats along our coastline. So in terms of going back to that marked recapture kind of population abundance estimate that we're eventually getting to, a lot of the research in South Africa so far has been very localized. And you can see something that we've seen over photo ID over the last couple of years is that a lot of these studies are multi-year projects. To get enough data from a boat-based survey working with this species, you have to really spend a lot of time on the ocean, and that's very costly and logistically very heavy. So this is what we work with. This is what our view is. One lone dolphin we're following with a big wave in the background often. So I deployed part of my PhD in 2021 an acoustic array, a pilot study in Mossel Bay. And we deployed 6 hydrophones throughout the linear array in Mossel Bay. And we had them out for about 2 weeks. In total, it was about 18 days. And we had about 2,500 hours of recordings. And one of the things I was looking for was to really understand detection rates. So you're looking for signature whistles and understanding how maybe important location is, and spatial and temporal distribution of those detections. So in this pilot study, I found that across our moorings, we had quite a difference in whistle count. So we had a lot of more activity of whistles produced around moorings 1 and 4. However, if you look at the bars there, that's unique individuals. And actually, there was a lot of unique individuals, or a similar number, across all of our moorings. One of the other things that we found that was really interesting was there was a diurnal pattern. So there was a lot more activity at night. So again, another advantage of using PAM, as a lot of you know, is you've got continuous recordings. And so we were getting a lot more activity at night, which is something we hadn't really discovered yet from our boat-based surveys. And what I was able to do as well is I did simultaneous boat surveys throughout those 18 days using photo ID to try and get a comparison of the two methods. And so across those 18 days when the moorings were deployed, we were able to get on the water for 13 days. And you can see here, these are boat tracks. So we really followed that kind of inshore area around the bay. And actually, we had 2 locations. These red dots are where we encountered humpback dolphins. So you can really see the difference there from the 2 methods in terms of if we only were doing boat-based surveys, we would have a really skewed impression of where the dolphins were and where the activity was. Whereas we know from our acoustics was that we would get a lot more use around the bay, and like I said, at night. One thing to highlight is our total recording effort for acoustics and our photo ID. They're both extremely low. Okay, so this is an elusive species, and very, very low encounter rates. But if you're on a boat and only seeing a dolphin 3.7% of the time, it can be quite a lot of time spent looking for them. But luckily, for the 0.15%, I was at home doing other PhD work. I was also able to do a cost per dolphin. And I just want to highlight that, yes, acoustics can be a bit cheaper because you don't have that boat-based survey element to it. But there was a lot of manual processing involved with the signature whistle identification. But all of this, with the advent of advances of machine learning, etc., will drastically reduce human time on these things in the future. So taking that pilot study, I then wanted to do a long-term deployment across the South Cape coast to try and get an abundance estimate based on using these signature whistles as individual acoustic labels for the whole of the South Cape coast. So we were obviously limited with time and equipment. We only had 5 units available to us for the 5-week period of deployment. So this is a study by Vermeulen et al., which I mentioned earlier, and this collated a lot of the photo ID data available since 2001. And these are all the recaptures and the photo ID databases. And so this is the South Coast period here. And I decided to deploy my units in this area from Mossel Bay to Plett, based on the movement of animals. So over a 28-day period in the study, they found that animals were moving about 100 kilometers, and this area here is about 150 kilometers. So hopefully what my aim was is if I put my array smack bang in the middle of this whole South Coast area, I'll get all of these guys moving, I'll get these guys moving, I'll get them moving through the middle. I thought it was a really great kind of smart idea. Some of the pre-work we did was I was looking at boat-based data, and this just confirms that movement. So data from a couple of weeks apart, they moved 140 kilometers. This is the same signature whistle in these 2 locations. So again, thought I was really smart. You can see where I'm going with this. So I deployed them in 3 bays, high-use bays. Buffels Bay was the first location. There hasn't been any acoustic data being collected there before, but there's been quite extensive data being collected acoustically in Mossel Bay and Plettenberg Bay before. So I was quite confident that I would be getting humpback dolphins. This is me and Guy. We dropped a lot of expensive equipment into the ocean and left it there for quite a while. And we got signature whistles. It was really, really exciting when we pulled out the equipment, and I was able to detect these signature whistles. We had 25 individuals over the course of 5 weeks. And this discovery curve down here, we had all of our hydrophones detecting signature whistles. And this is the catalogue of whistles that we detected. And so that was all very exciting and encouraging. One thing to note as well is that there's a paper in prep at the moment that Tess and I are collating with collaborators and building a Sousa catalogue, so a humpback dolphin signature whistle catalogue that we can then refer to, similar to what they have in Namibia, So we actually only needed one detection of a signature whistle for it to match the catalogue for it to be counted as a capture. So we didn't need that temporal bout necessarily, which was really useful in a vocally elusive species such as humpback dolphins. One of the things I found, though, was that we had a really high number of recaptures. Okay? And if you look at the cumulative discovery curve of all the moorings, towards the end, it does taper off towards the end of the 5 weeks. And if you're looking at an open population, this is kind of the thing that you're looking for. Okay? You're kind of expecting a lot of single recaptures or even 2 recaptures if you've got an open population moving through your area. This is from the bottlenose dolphin study done by Rasinger in Algoa Bay a few years ago, and you can see how open that population is. We basically detected every single animal acoustically in the area during that period, which produced abundance estimates very, very similar to the number of signature whistles or individuals detected. And so basically, I can say that I produced an answer. So in these 5 weeks, I got a really good understanding of how many animals were in that area across those 5 weeks, but it doesn't really tell me much about the animals that didn't enter that area or outside. And so clearly, I needed to kind of expand my geographic range. It was a little bit too limited in my scale. And you can see here, this is from the mask from the SECR models, and this is the whole of the range here. And actually, in future, by moving your array to cover much further coverage of my population's range, I'll be able to get a lot more unique individuals. And so from this data and from the pilot studies, and kind of one of the key outputs is that location isn't as important in humpback dolphins, or especially in threatened species where you're really just trying to capture as many individuals as possible to get a really good abundance estimate or reliable estimate that can then go into trend data. When you're working with threatened species, it's much more important to get a robust estimate that can then be repeated over time at the lowest cost and with the greatest feasibility, rather than that fine-scale understanding of high detection probability in a fine-scale area that other species are leaning towards. But thank you to all my collaborators and also everyone who helped me on this for collecting all the data. It was a huge project, and I'm just at the end of it now, so yeah, this is all very fresh in the mind. And because it's an acoustics conference, and because I didn't have any acoustics, this is the last little fleeting moment. This is a humpback dolphin in Mozambique, called Perm, and yeah, this is what they sound like. Thank you, everyone.
Thank you so much, Sasha. We have time for 1 or 2 questions, if anyone has. Okay, cool. Okay.